Okay, so let's have a look at some Python to do with our Sudoku problem. So, you may not be familiar with it, but the type of thing we're going to look at today in Python is to do with lists. So lists are one of Python's collections. If you're unfamiliar with lists, they're a bit like arrays in other programming languages. Certainly Scratch has got those in. It's basically a collection of data that we can all refer to under one variable name, and each item in the list has got a particular place in the list, its index value, and we can access any item in the list by specifying its index value. So let's just have a quick look at the command line. I'm just going to create a quick list with the numbers 1, 2, 3 and 4 in it. List, you can see I've got the square brackets around. That makes it a list in Python terms, and the commas obviously separate each item. So we've got 4 items in this list. Because we're in the shell, we can obviously just hit the name of the list and it'll print me out the fact it's a list. Again, you can see that's a good indication there because of the square brackets. There are 4 elements and they are indexed 0, 1, 2 and 3. So remember, just like all most of the programming languages, excluding Scratch, which starts from 1, Python starts with the first element being index value 0. So if I want to index a particular item in the list, then I can just say item 0 and I'll get the value 1. And we do nums 3, then obviously I'll get item 3 in the list, which is the value 4. So great, got things in lists. What can I do with lists? Well, I can add things to lists, so I can say nums.append and put the value 44 put the value 44 at the end of the list. And if I now look at nums, you can see it's got 44. I can take stuff off the end of the list or remove a particular item. I'm just going to pop this back off. So nums.pop. You can see it actually gave me the value 44 back. That's because it's removed it from the list and returned it as part of that call. If I now look at nums, you can see the 44's gone. And obviously lists are what we call mutable, which means we can change the list. So if I do nums brackets 1, which is element number 1 of the list, so that's where the value 2 is, I can now change that to say 44 and look at nums. You can see that's changed. And what can these items in the list be? Well, actually they can be anything. I've just happened to have chose numbers here, but if I do nums brackets 2, which is where the value 3 is at the moment, I can put some text in there. I'll put the text for the word 3 in. That might help if I use the equal sign, or the assignment as I ought to call it. Okay, so let's just have a quick look at nums again. You can see it's put 3 in there. Now the really clever thing about Python is each element in the list can be anything. And in fact, each element can be a list in itself. So if I now go and look at the last element of this list, nums brackets 3, which is where I've got the value 4 at the moment, and I set that to be 55, 66, 77 and hit return. I wonder what nums is going to look like now. Well, nums is a list of still 4 elements. The first element is the value 1, the second element is the value 44, which is an integer, the third element is the string 3, and the fourth element is a list. And what does that list contain? That list itself contains 3 numbers. So what we've been able to do here effectively is build up a list which contains integers, strings and lists. Okay, so now you've got the idea of a list containing lists. How does that apply to the Python program? Well, we're going to have a look at it, but first let's just have a quick look at this grid here. So this is representing a Sudoku board. You can see it's got 9 columns across the top, and each column has got 9 rows going down the side. To show you what we're doing, we're just going to look at this top kind of third of the board, or ninth of the board really, the first 3 columns and the first 3 rows in those 3 columns. So we have 3 columns, column A, column B and column C, and to want to represent what's in each of these columns, and again just the first 3 for the moment in our Python program. So let's pull up our Python shell. We're going to do this now within a file because it's going to get a bit more complicated to do everything at the command line. So let's just have a look how this is going to work. We're going to put the two together there so we can see what's going on. So just like all programs, I need a def main. That's where my code is going to go, and a main at the bottom as it gets a bit more complex. So I need to first of all represent what's in column A, which is a 3, a 9 and a 7. So I just want to represent my 3, 9 and 7. So I'm going to create a list to do that. I'm going to call it column A, because it's for column A, and it's going to be a list, and it's going to have 3 and 9 and 7 in there. Okay. Similarly, I want to do one for column B and one for column C. So the quickest way to do that, probably not the quickest way, but it's the way we're going to do it. So I want one for column B, and I want one for column C. So column B is 5, 4 and 2. So in there I want a 5, 4 and a 2, and column C is my 6 and 8 and 1. So those three lists now, col A, col B, col C, represent the three columns, and you can see that each element within the list represents a particular row. So in column A, the first element, where there's a 3, represents the first row here, where there's a 3 within row A, and then the 9 is the second row, and the 3 is the third row. Now remember, the indexing won't go 1, 2, 3 as it's shown down here. It'll go 0, 1 and 2. Something we've got to bear in mind. So at the moment it's kind of okay, but we've basically got three separate lists, one for each column. Really what I want to do is combine those into an all-encompassing list called the grid. And what's the grid going to be? The grid is going to be a list, and the list is going to contain each of the columns within the grid. So our grid is a list of columns, which obviously are column A, column B and column C. Okay, so the only thing I did wrong there is get a capital C for column B. Okay, and if that's worked, I just realised I put it all after main, I'll move that in a minute. If that's all worked, what we're going to do is print our grid just to see what it's going to look like. So I just need to move main down to the bottom there. Okay, so let's run that program and see what we get. So run module. Just going to save it on the desktop now, called lists. And hey presto, we've got some output. So let's have a look at the structure of this output, make sure we understand it. Well, first of all, the square brackets around the whole thing, so that means it's a list. And there are commas here and here, which means it's got three elements in. That's the first element in the list, that's the second element in the list, sorry, that's the second element, and that's the third element in the list. And what are each of those elements? Well, the first element is, it's got square brackets at the beginning and end, so it's a list. It's got two commas in it, so it's got three elements, the numbers 3, 9 and 7, which clearly represent 3, 9 and 7 going down here. 5, 4 and 2 represent 5, 4 and 2, so they represent the second column, and 6, 8 and 1, 6, 8 and 1 represent the third column. So our single list called grid is actually now a two-dimensional array in some of the languages, or in Python we refer this as a list of lists. Now hopefully you can see how we can extend that. It's just going to be a bit bigger and a bit more cumbersome on the screen, but to represent the whole Sudoku board we really need a list of 9 elements, one for each of the 9 columns, and in each column we want another list to represent each row, each element within the row. So we'll end up with a 9 by 9 grid, or a list of 9 items, and each item of those will be a list. Okay, so now we've got that, how does it help us? Well, what it means is we can index any particular cell within this grid just by using its references. So let's just understand what's going on here. So initially we're printing the whole grid. What I now also want to do is have a look what happens if I just print grid 1. So just looking at the first, that's the second element in the grid. We're going to do grid 0. Let's just run that and see what happens. Okay, so you can see there's printing the whole grid, and when we print item 0 of the list, 397, we got the first element of the list, which is the list containing 3, 9 and 7. So the next obvious step is, can I, after having indexed the main list to get this sublist 3, 9 and 7 representing the first column, can I then index this column as well at the same time to get a particular cell? So let's go back and have a look at that. So now I'm going to do print grid 0, and I'm going to do another bracket like this with 0. So grid, the first 0 gets me the list which was 3, 9 and 7, and the second 0 then indexes this, so should just get me the number 3. Let's have a look if that runs. Hey presto. So what that's allowed us to do now is, looking at the code, give me a way to index this grid using the X reference. So that's along here, which particular column I want, and then the Y reference coming down the screen to say which particular row I want. So let's have a look. Let's say I want to get to this particular cell here, 8. It's column 0, column 1, column 2. So I need that to be a 2 in there. And this is row 0 and this is row 1. So that hopefully should access that cell there, 2, 8. And if it does, when we print this 2, 8, we should get the number 8. Let's try that. Hey presto. So this has given me a way now to index essentially a 2-dimensional array, and our 2-dimensional array is representing the grid, and we're representing it with the first number, the X coordinate, which tells me which row it's in, and the next number being the Y coordinate, telling me, sorry, the first one is telling me which column it's in, that's the X coordinate, and the second one is the Y coordinate telling me which particular row it's in. So remember, from a kind of a graphs and a maths point of view, one thing that some people find a bit difficult here is the origin is up here in the top left of the square. So this is the origin, and then we're indexing 0, 1, 2, 3 going across. That's pretty standard, the way we index X. But Y, we're coming down here indexing 0, 1, 2, 3, 4, 5. And I think a lot of people, obviously normally when you're coming down a particular way like this, think about the numbers becoming more negative from the origin, so like -1, -2. Well, just the way we've decided to implement it, we're calling this row 0, row 1, row 2, row 3. So that'll hopefully make sense. Okay, now you've got the idea of that, you can see that we can index a particular item. Can I change a particular item? So I'm just going to go for grid. I'm going to go for the bottom corner, which is 2, 2. So that is column 2. This is column 2 and row 2, so this should be the element here where I've got a 1, and I'm just going to put a space in there instead of the 2, because I'm going to say maybe represent this as a number that I don't yet know, and print the grid and see what happens. Okay, so there's our grid. You can see what it's done. The number 1 here has now been taken out and it's got a space in there. So if we were processing this could be an unknown number, and our process goes along, and a little bit of time later we actually figure out what the number is using some kind of logic, and when we do, we change it back to the number 1. So let's see if I can set it back to a 1 and reprint grid. Okay, yeah, there. So it started with a 1, we replaced it by a space just to simulate it was an unknown number. We've done some processing, we've calculated it, and now we know it's the number 1, so we've changed that back. Okay, so you've got the idea how we can now process a grid, how we can represent it by a list of lists. In other programming languages called a 2-dimensional array. Your challenge now is, can you extend this now to think about a full Sudoku board which has got 9 columns and 9 rows. So this grid here will be a list of lists, 9 by 9, and you can then access any particular element in that list representing a particular cell. And again, the numbers will be 1 through 9 for the cells that you know, and spaces for the cells that you don't know. So have a go at printing out, setting up that list and printing the list out. See if you can get it in a bit of a nicer order if we were to print the grid than just the separate elements like this. And that's what we'll have a look at next time. Okay, thanks, bye.